Hello David, I hope you are doing well. So in previous three lectures we did the most important part of mathematics and the most important branch of mathematics, that is calculus, in which we did the two major topics. We studied the two major topics, differentiation and integration. The process of taking derivative of some function is called differentiation, and the inverse process of differentiation is called integration. Now, like f y is equal to f of x as any function, f y is equal to f of x. This is any function, right, in which x is independent variable and y is dependent variable. Actually, y depends on x, so y will change with respect to x, and this change in y is actually represented by dy, change in y with respect to change in x. This is called derivative of the function, or in other words we can say that change in y with respect to change in x, this is called average rate of change, average rate of change. And change in y with respect to change in x such that change in x is very small, nearly approaches to 0, then such average rate of change is called derivative of the function, or we can say that this is called instantaneous rate of change of dependent variable with respect to independent variable, and this instantaneous rate of change is called derivative of the function. So, what actually this thing means? This dy means small change in y with respect to small change in x. This is called derivative of the function. So, derivative is actually the name of change, right. And then we studied the power rule, and we studied that derivative of constant is 0. Why 0? Because there is no change in constant, and derivative is actually change. So, derivative of constant is 0, derivative of x with respect to x is 1. Similarly, then we did the power rule, right, f x to the power n, then it will be, its derivative will be n x to the power n minus 1. Then we did the extended power rule, u to the power n, if there is a function having power on it, what will be its derivative? We will multiply the power and subtract the power and multiply it with derivative of the function. Then we studied product rule, quotient rule, then we studied the derivative of trigonometric functions and exponential function and logarithmic functions, right. Now, as we did these things, after that we did the application of derivative. So, what is the application of derivative? Application of derivatives, or we can say differentiation. So, using differentiation we can find minimas and maximas, and maximas. So, using differentiation we can find maximas and minimas in the graph of function, right. So, if there is any graph, like if there is consumption, the graph of the consumption of electricity with respect to time of the whole day, or we can say of the whole month, right. So, using derivative we can find that at what day of the month, or we can say that at what time of the day there is a minimum consumption of electricity, right, or at what time of the day there is a maximum consumption of electricity, right. So, for that thing, for finding minimas and maximas in the graph of function, we studied the second derivative test, right, and first derivative test, right, and then we studied the point of inflection and the concavity concept, right. So, I hope you studied this topic. If not, then no problem, you can revise and we will discuss in the Zoom session. After that, we starts integration, right? So what is integration? So integration is actually the inverse process of differentiation, or we can say it is anti-derivation. Integration is actually anti-derivation, right? Like derivative of x is 1, so integral of 1 is with respect to x is x, right? So we studied the basic things of the integration, right? And the direct integration rule, like the integration of sin x, cos x, tangent x, integration of secant square x, and what will be the integration of a to the power u, right? Like integration of a to the power u will be what? It will be a to the power u divided by natural log of a and multiply it with derivative of u plus c. Similarly, the integration of e to the power u will be what? It will be again e to the power u and multiply it with derivative of u, right? Why I am focusing more on integration and differentiation? Because in the coming subjects, these topics are very important, right? So based on these concepts, you can solve Fourier series, Fourier transform, Laplace transform, right, and other things. So this is actually the backbone of mathematics, and mathematics is the backbone of the engineering, right? So you must know these things before doing the other subjects, or before starting the other subjects, right? So these are the basic integration techniques, integration formulas we studied. You must know these things. Now, so in the previous lecture I told you that first, when there is a question of integration, first we will see to directly solve that integration, right? Directly solve. Directly solve mean like you know it, it's integration directly. Like if I say the integration of x square plus e to the power 2x dx, right? So you can say that its integration is x square by 2 plus e to the power 2x by 2 plus c, right? So this is direct integration. The second technique is, if the question is not solvable directly, then you will try to simplify the question, simplify and then solve. And again, like if I solve the question like x plus 1 whole cube dx, right, or x square plus 1 whole cube, right? So this is actually the function having power on it. So as this is not soluble directly, so first we will expand this formula. This is actually a plus b whole cube formula, right? So the formula a cube plus b cube, this is equal to a cube, sorry, this is not a cube plus b cube, this is a plus b whole cube formula, a plus b whole cube. So this is equal to, so David, this is equal to a cube plus b cube plus 3a square b plus 3ab square, right? So first we will expand the formula. This is a cube, so 2 3 is 6 plus b cube, 1 cube is 1 plus 3a square b, right, plus 3ab square. Then you can take its integration. So its integration is x to the power 7 over 7 plus x plus 3x to the power 5 over 5 plus 3x cube over 3 plus c, right, David? So first, when there is a question of integration, so you will try to solve it directly, right, like this. If it is not solvable directly, then you will see that if it's if we can simplify it and then solve, right? Like here it is not soluble directly, so first I expand the formula then solve. And then the third option, if these both not works, then the third option is rules of integration. Rules of integration, right? So the major rule of integration, and the first rule of integration is the power rule, right? And what is actually the power rule of integration? Power rule of integration says that if there is a function having power on it and its derivative exists near that function, so what will be its integration? We will increase the power, the whole power, and divide it by the whole power plus c, right? It is the power rule of the function. If there is a function having power on it, I hope you are listening me, David. There is a function and here is power on it, and the derivative of the inside function exists near that function. Then what will be its integration? We will increase the whole power by 1 and divide it with the whole power. Like if I say question, like if there is a question of 4x plus 3 whole to the power 3 dx, right? So this is a function having power on it, and if there is a derivative exist or not. So the derivative of this function is 4, right? So we can multiply 4 here and divide it 4 here, right? So now it is perfect to be solved by using power rule. So this is the function having power on it, and the derivative of this function exists near this, right? So what will be the integration? We will increase the power and divided it with the whole power plus c. So this will be 1 over 16 into 4x plus 3 whole to the power 4 plus c. So this is actually the power rule of integration, right? So let's do some other question on it, this too, because in mathematics it is very important to practice the question, right? So if there is another question like integration of 3x square plus 1 whole to the power 9 and x dx, right? So this is a function having power on it, and the derivative of function exists or not. So the derivative of this function is actually 6, right? So we can multiply here 6 and divide here 6, right? So this is a function having power on it and its derivative exists near this. So what is the power rule of integration? We will increase the power by 1 and divided it with the whole power, right? So this will be 1 over 60 into 3x square plus 1 whole to the power 10 plus c. So this is actually the power rule of integration. So we studied two things, right? The first one is use direct integration, right? So let's do some questions using direct integration, and the second rule is the second approach to solve the integration problem is to simplify and then solve, right? Then solve directly. Like if the question is integration of 3 v to the power 5 minus v to the power 5 over 3 whole dv. So this is actually directly solvable. So we can write it like 3 v to the power 5 dv minus integral v to the power 5 over 3 dv, right? So it is actually 3 v to the power 6 over 6 minus v to the power 5 over 3 plus 1, that is equal to 8 over 3 divided by 8 over 3 plus c. So this is the integration. So this is actually the question based on the first, like it is directly solvable, right? Now the second technique is first simplify and then solve. First simplify and then solve, right? And we did the question based on the based on the direct integration. The question may be in the form of 1 over z cube minus 3 over z square whole dz. So what will you do? We can write this question as z to the power minus 3 dz minus 3 and z to the power minus 2 dz. Now its integration is z to the power minus 2 because we increase power by 1 and divide by 4 minus 2, and this is z to the power minus 1 plus 1. So this is minus 1 over 2 z square and minus minus plus 3 over z plus c, right? So this is actually questions solving using direct integration. Now the second thing is the power rule of integration, right? First is direct integration, second is simplify and then solve, and the third is using rules of integration, right? So like if the question is in the form of integral of x square plus 1 whole square dx. Now this is a function having power on it, right? And their derivative here exists or not. So there is no derivative of this function exists near this, right? So we cannot solve this question using power rule of the integration. So what will we do? We will first simplify the question, and we can simplify it by using a plus b whole square formula. It is a square plus b square plus 2ab, right, David? So and then its integration will be x to the power 5 divided by 5 plus x plus 2 x cube over 3 plus c, right? So this was the question based on the second scenario, that actually this is a function having power on it. This is a function having power on it, and its derivative does not exist here. So we cannot apply power rule on this function, right? So first we will simplify the question and then solve. Now here is like if the question is in the form of integral 1 plus under root x whole to the power 4 multiplied by 1 over under root x dx. Now here is another method, that is actually integration by substitution. Sometimes the integration power rule, we can solve the question using integration power rule, but on substitution method, because sometimes we didn't know that if this is a function having power on it and the derivative of this function exists here or not, because sometimes we don't know the direct derivative of the insider function, right? If this function is x square plus 1 whole cube and x dx, then we know that the derivative of x square plus 1 is 2x, right here. So we can say that the derivative exists here, but in this case we don't know the exact derivative of this function, right? So in that case, what will you do? You will substitute the insider function by u and then take its derivative. So what will be your goal in solving question by using substitution method? You will suppose the insider function using u, right? And you will try that to write the another part is a du in the form of du. So we substitute this as u, and du by dx is actually its derivative, that will be 1 over 2 under root x. How this become? Actually f u is equal to under root x, right? Or we can say that under root x plus 1, or we can say 1 plus under root x. So du or dx will be derivative of 1 is 0, and this is actually x to the power 1 over 2. So 1 over 2 will be like here, and subtract minus 1. So this will be 1 over 2 x to the power 1 over 2. So we can write it 1 over 2 under root x, right? So whenever, I hope David you are listening me. So whenever you are solving the question and there is a power on it on the insider function, and you don't know the exact derivative of the insider function, so what will you do? You will take the inside function as a u, and you will try it to replace the other part as a du, right? So you take this as a u and du by dx is 1 over 2 under root x. So this implies that this is actually 2 du is equal to 1 over under root x dx, right? So instead of this thing you can write 2 du, instead of this thing you can write u. So the question will become integral of u to the power 4 and du, 2 du. So we will keep 2 outside. So its integration will be u to the power 5 over 5 plus c, and at last replace this by u. So u is actually 1 plus under root x whole to the power 5 plus c. So this is actually integration by substitution method, right? Let's do another question of using integration by substitution. Like if the question is integration of t minus 2 divided by t square minus 4t plus 3 whole cube dt. So let u is equal to t square minus 4t plus 3, right? Why I took t square minus 4t plus 3 is u? Because there is a power on it, right? So I will try to take the u or substitute that value in the integration which are under some power, right? So this is u. So now du will be equal to 2d minus 4 whole dt, right? So what will we do? As I took this as a u, so I will try at this to write in the form of du. So this du will be 2 is common, so this is t minus 2 dt. So this implies that 1 over 2 du is equal to t minus 2 dt. So now if I replace the whole question using u, so it will be in the form of 1 over t square minus 4t plus 3 whole to the power 3 dot t minus 2 dt. So this will be written as 1 over u cube and multiply by 1 over 2 du. So this is 1 over 2 and u to the power minus 3 du. So then you can integrate it by minus 2 divided by minus 2 plus c, and at last you will replace the u, so that is t square minus 4t plus 3 whole cube plus c. So this was the solving the question of the integration using power rule and using on substitution method. So as the lecture will become too much long, so I will solve some question and send you on WhatsApp, right? So in previous some lectures we did the major part of integration, differentiation, and then we start integration. And in integration, if there is a question of integration, first we will try to solve it directly, right? And if it is not solvable directly, then we will try to simplify the question and then solve, right? And the third one is using any rule of integration. So I think it's enough for today. So in the next lecture I will do some more techniques to solve the question based on the integration, right? And the rules of integration, and 2 to 3 lecture we will try to finish the whole integration. Okay, thank you, have a good day.